Welcome to Math with Mr. J. In this video, I'm going to go through a mini course on the basics of fractions. This video will give us a nice foundation, a nice base that we can build off of. We will start with what fractions are, then we will move to topics like equal parts, unit fractions, fractions of shapes, fractions of groups, and then we will end with fractions on number lines. All topics are time-stamped and put into chapters, so feel free to jump around. Let's jump into what fractions are. Now, simply put, a fraction represents part of a whole. Let's jump into some examples here to help us understand what this means. And we're going to start with this whole pizza right here. So we have one whole pizza. If we had two whole pizzas, we'd write 2. If we had 3 pizzas, we'd write 3. So on and so forth. The point being, we use whole numbers to represent wholes. So nothing new here. But what if we only have part of a whole? For example, let's look at this part of a whole pizza right here. Do we have a whole pizza? No. So we need to use a fraction to represent this amount. Let's say that this amount is what was eaten and this is what is left. So basically, what part of the whole pizza do we have left? Let's write a fraction, so we need to use numbers to represent what is left. Now, when writing fractions, we have a top number, a fraction bar, and then a bottom number. So fractions have 2 numbers. Again, one on top and one on the bottom. And then they are separated by a fraction bar. Let's start with the bottom number. That's going to be how many total equal parts the whole has been divided into. So as far as this pizza, how many parts make up the whole pizza? Well, 1, 2. So 2 is our bottom number. We need our fraction bar to separate the top and bottom number, and now we need the top number. The top number is going to be how many of the equal parts we have out of the whole. So in this case, we are looking at and want the part of the pizza that is left. Well, we have 1 part left. So 1 is our top number, and that's our fraction. 1 over 2. And we say this fraction 1/2. So we have 1/2 of the pizza left. This fraction represents this amount. We have 1 part left out of the 2 total parts. Now, before we move on to more examples, I do want to cover what the top number of a fraction is called and what the bottom number of a fraction is called. We call the top number of a fraction the numerator. The bottom number of a fraction is called the denominator. Think denominator down. Match those D's, and that can help us remember that one. Let's move on to some more examples. So here are some more examples, and we will go through 6 in total. 2 more with pizzas, and then we will go from there. For numbers 1 and 2 here, let's write fractions to represent how much pizza is left. So let's look at number 1 first. We will start with how many total equal parts the whole has been divided into. The whole has been divided into 1, 2, 3, 4 equal parts. So that's our denominator, the bottom number of the fraction. Then we need the fraction bar, and now we need the numerator, the top number. The numerator is going to be how many equal parts of the whole pizza we have left. Well, it looks like we have 1, 2, 3, 4 parts left. So that's our numerator. So our fraction here to represent the amount of pizza left is 4 over 4, which we would say 4/4. Now you may be thinking, we have a whole pizza here, 1 whole pizza. And you're right. So why would we write a fraction? Well, we have 4 out of 4 pieces left. So we were able to write that fraction 4 over 4. That fraction actually equals 1 whole. So something to keep in mind when it comes to fractions, when we have the same number on top and the bottom, that's equal to 1 whole. And this picture of the pizza is a good visual of that. Let's move on to number 2, and we can tell right away that we do not have the whole pizza left. So let's write a fraction to represent this amount. Let's start with how many equal parts the whole pizza was divided into. That's going to be our denominator. We have 1, 2, 3, 4 equal parts. So that's our denominator. Now we need the numerator. So how many equal parts of the pizza do we have left? How many pieces of the pizza do we have left? Well, 1, 2, 3. So that's our numerator. And we're done. That's our fraction. 3 over 4. And we would say this 3/4. That fraction tells us that we have 3 pieces of pizza left out of the 4 total pieces. So 3 out of 4 parts. Let's move on to some more examples. Taking a look at numbers 3 through 6, we're going to write fractions to represent the shaded part of each shape, so the colored in part. And you'll notice that none of these shapes are completely colored in, so we don't have any holes here. We have parts of holes. So we need to write fractions to represent that. Let's start by taking a look at number 3. So how many total equal parts has the whole circle, been divided into? Well, 1, 2, 3. So that's our denominator. And you'll notice I'm saying equal parts throughout this video. When it comes to fractions, we need to be working with equal parts. So parts that are the same size. So something to keep in mind when it comes to fractions. Now we need our numerator. So how many parts are shaded? Well, 1, 2. So that's the top number of this fraction. So we get 2 over 3, which we would say 2/3. That fraction tells us that 2 out of the 3 parts are shaded. We have part of the whole circle shaded. Let's move on to number 4, and we'll start with how many equal parts the whole has been divided into. Well, 1, 2, 3, 4. So that's our denominator. Now we need how many equal parts have been shaded. 1. So that's our numerator. So our fraction here, 1 over 4, which we would say 1/4. 1 out of 4 parts are shaded. Moving on to number 5, let's start with how many total equal parts the whole rectangle has been divided into. 1, 2, 3, 4, 5, 6. So that's our denominator. Now we need how many equal parts have been shaded. 1, 2, 3, 4. So that's our numerator. We get 4 over 6, which we would say 4/6. 4 out of 6 parts are shaded. Lastly, let's take a look at number 6. How many equal parts has this whole been divided into? 1, 2, 3, 4, 5, 6, 7, 8. So 8 is our denominator. Now we need how many equal parts have been shaded. 1, 2, 3, 4, 5. So that's our numerator. And we get 5 over 8. We would say this 5/8. 5 out of 8 parts are shaded. So there's a basic intro to what fractions are. Let's build on this and move on to other topics, starting with equal parts. In this section, we're going to look at identifying equal parts, which is an important part of working with and understanding fractions. Remember, a fraction represents part of a whole. So when working with fractions, we have a whole divided into parts, and the parts need to be equal. The parts need to be the same size. Let's jump into our examples, starting with number 1 and see what this means and looks like. For number 1, we are looking at halves. That means we want two equal parts. Let's say that we want to split a chocolate chip cookie in half. Let's look at cookie A. So this cookie right here. Do we have halves, so two equal parts? No, the right part is bigger than the left part. This would not be a fair split if we were sharing this cookie. This is not a representation of halves, two equal parts. So no, we do not have halves here. How about cookie B? So this cookie right here. Do we have halves, two equal parts? Yes, we do have halves here. This would be a fair split. Each part here is one half of the whole cookie, and those two halves make the whole. So keep in mind, when working with fractions, we need equal parts, so parts that are the same size. Let's move on to number 2, where we are going to look at fourths. So fourths means we have four equal parts. Let's start with A. So do we have fourths here? Four equal parts, four parts that are the same size. Yes, we do have fourths here. All four parts are equal. Now each part is 1/4 of the whole. So this is 1/4 of the whole. This is 1/4 of the whole. This is 1/4, and this is 1/4. And all four of those 1/4ths make up the whole. Moving down to B, do we have fourths here? So four equal parts. Yes, and again, each part is going to be 1/4 of the whole. So again, yes, we have fourths for B. Moving on to C, do we have fourths here? No, we do not. These parts are not equal. They are not the same size. So we do not have fourths. Since the parts are not equal, each part is not 1/4 of the whole. So again, we do not have fourths here. Lastly, for number 2, let's move on to D. So do we have fourths here? Yes, each part is equal. Each part is the same size. So, yes, each of those four equal parts is 1/4 of the whole. So again, yes, we have fourths here. Let's move on to some more examples. Taking a look at number 3, we're going to continue identifying equal parts. But instead of yes or no, like numbers 1 and 2, we're going to mark each example as having equal parts or unequal parts. Equal parts are the same size, unequal parts are not the same size. Let's start with A. Is the whole divided into equal parts or unequal parts? Well, that circle is divided into unequal parts. Although we have four parts here, these are not fourths because they are unequal. They're not the same size. Moving on to B, do we have equal or unequal parts? Well, we have three equal parts here. So these are equal. This is what we call thirds. Each part is 1/3 of the whole. So this is 1/3 of the whole. This is 1/3 of the whole. And this is 1/3 of the whole. And if we take all three of those 1/3s, that gives us the whole. Moving on to C, do we have equal or unequal parts here? Well, these are unequal parts. They are not the same size. Let's move on to number 4, where we need to write the number of equal parts each whole is divided into. Let's start with A. We have 1, 2, 3, 4, 5, 6 equal parts. So 6 equal parts. This is what we call sixths. So each equal part is 1/6 of the whole. Moving on to B, we have a triangle divided into 1, 2 equal parts. So we have halves here. Each part is 1/2 of the whole. Lastly, for C, we have 1, 2, 3, 4, 5 equal parts. So fifths. Each part is 1/5 of the whole. So there's our section on identifying equal parts. Let's move on to naming equal parts. Here's our section on naming equal parts. And like we've already talked about in this video, when it comes to fractions, a whole is divided into equal parts. And these equal parts have names. Knowing these names is important when it comes to working with fractions. We will cover 2 equal parts up to 10 equal parts in this video. Now keep in mind, do fractions stop at 10 equal parts? No, we can have 12 equal parts, 25 equal parts, 30 equal parts, whatever the case may be. But this is a nice place to start and build off of. Let's jump into our examples where we need to figure out the number of equal parts a whole has been divided into, and then we will match that to the name for those equal parts. For example, number 1, this circle, our whole, has been divided into 1, 2, 3 equal parts. So 3 equal parts. We call 3 equal parts thirds. So let's put a B next to number 1 and cross off thirds. Now each of the equal parts is 1/3 of the whole. So this is 1/3 of the whole circle. This is 1/3 of the whole circle. And this is 1/3 of the whole circle. Let's move on to number 2. This whole has been divided into 1, 2, 3, 4, 5, 6 equal parts. So 6 equal parts. We call 6 equal parts sixths. So let's put an E next to number 2 and cross off sixths. Now each one of those equal parts is 1/6 of the whole. Moving on to number 3, we have a triangle, that's our whole, and it has been divided into 1, 2 equal parts. 2 equal parts, well, we call 2 equal parts halves. So let's put an A next to number 3 and cross off halves. Each one of those equal parts is 1/2 of the whole. Next, number 4, we have a square, that's our whole, and it has been divided into 1, 2, 3, 4, 5 equal parts. So 5 equal parts, we call 5 equal parts fifths. So let's put a D next to number 4 and cross off fifths. Now each one of those equal parts is 1/5 of the whole square. Moving on to number 5, this whole has been divided into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. We call 8 equal parts eighths. So let's put a G next to number 5 and cross off eighths. Each one of those equal parts is 1/8 of the whole. Moving on to number 6, this whole has been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. We call 10 equal parts tenths. So let's put an I next to number 6 and cross off tenths. Each one of those equal parts is 1/10 of the whole. Taking a look at number 7 now, we have a circle, that's our whole, and this circle has been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. 9 equal parts we call ninths. So let's put an H next to number 7 and cross off ninths. Each one of those equal parts is 1/9 of the circle, the whole circle. Next, for number 8, we have a square here. That's our whole. And this square has been divided into 1, 2, 3, 4 equal parts. 4 equal parts we call fourths. So let's put a C next to number 8 and cross off fourths. Each one of those equal parts is 1/4 of the whole. And then lastly, number 9, we have a whole that has been divided into 1, 2, 3, 4, 5, 6, 7. 7 equal parts. We call 7 equal parts sevenths. So let's put an F next to number 9 and cross off sevenths. Each one of those equal parts is 1/7 of the whole. So there's how to name equal parts. Let's move on to unit fractions. Now let's take a look at unit fractions. Now remember, when it comes to fractions, a whole is divided into equal parts. Each one of those equal parts is what we call a unit fraction. So one equal part of a whole is a unit fraction. And unit fractions have a numerator, so top number, of 1. Understanding unit fractions helps our overall understanding of fractions and helps us when working with fractions. So let's jump into our examples here, starting with number 1, where we need to write the unit fraction that represents each equal part of the whole. So the first thing that we need to do is figure out how many equal parts the whole circle, has been divided into. Well, 1, 2, 3 equal parts. So each one of those equal parts is what fraction of the whole? Well, since we have 3 total equal parts, the denominator is going to be 3. So denominator is going to be 3. And then as far as the numerator, each equal part is 1 out of the 3 total equal parts. So our numerator is 1. So this equal part is 1/3 of the whole circle. This equal part is 1/3 of the whole circle. And this equal part is 1/3 of the whole circle. So the unit fraction that represents each equal part of the whole here is 1/3. Let's move on to number 2. So what unit fraction represents each equal part of the whole? Well, we have 1, 2, 3, 4 equal parts. The whole square has been divided into 4 equal parts. So 4 is going to be our denominator. And then each equal part is 1 out of the 4 total equal parts. So this is 1/4 of the whole, 1 equal part out of the 4 total equal parts. This is 1/4 of the whole, this is 1/4 of the whole, and this is 1/4 of the whole. So 1/4 is the unit fraction that represents each equal part of the whole. Let's move on to number 3. So we will start by seeing how many equal parts the whole has been divided into. 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So each equal part is 1 out of 8 total equal parts. So our unit fraction here is 1/8. This equal part is 1/8 of the whole. This is 1/8 of the whole. This is 1/8. 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 And this is 1/8. So 1/8 is the unit fraction that represents each equal part of the whole. Moving on to number 4, let's see how many equal parts this whole rectangle has been divided into. 1, 2, 3, 4, 5. So each equal part is 1 out of 5 total equal parts. Our unit fraction here is 1/5. So this is 1/5 of the whole. This is 1/5. This is 1/5. This is 1/5. And this is 1/5. So 1/5 is the unit fraction that represents each equal part of the whole. Let's move on to numbers 5 through 8. Here are numbers 5 through 8. And for these, we're going to write what fraction, and these will all be unit fractions, of each shape is shaded. Let's start with number 5. The whole circle, has been divided into two equal parts. 1, 2. So our denominator is 2. Now, one of the two equal parts is shaded, so our numerator is 1. Our unit fraction is 1/2. Moving on to number 6, the whole has been divided into 1, 2, 3, 4, 5, 6 equal parts. So 6 is our denominator. One of the equal parts is shaded, so 1 is our numerator. Our unit fraction here, 1/6. Now, before moving on to number 7, I want us to take a look at something that's going to help our understanding of unit fractions. For numbers 5 and 6, that whole circle is the exact same size. So going off of that, which unit fraction do you think is greater? Do you think is larger? 1/2 or 1/6? And we can just look at which shaded part is larger. Well, 1/2. And we can think of these two circles like two pizzas that are the same size. Is 1/2 of the pizza more, or is 1/6 of the pizza more? Well, we can see that 1/2 is more. So one thing I want us to think about and keep in mind when it comes to unit fractions, the larger the denominator is, the smaller the parts will be. And we can also think the smaller the denominator, the larger the parts will be, which kind of sounds like it doesn't make sense. So why would it be that the larger the denominator, the smaller the parts, or the smaller the denominator, the larger the parts? Well, think about it. The larger the denominator, that means the whole is being divided into more equal parts. And the more parts we have, the smaller they are going to be. Like 1/6 right here compared to 1/2. And speaking of 1/2, the smaller the denominator, the less parts the whole is divided into. So the parts are larger, like right here. Now, the focus of this video isn't comparing unit fractions. We will get more into that in another video. But I at least wanted to mention this, so something to think about. Let's move on to number 7. The whole rectangle has been divided into 1, 2, 3, 4, 5, 6, 7 equal parts. So our denominator is 7. And then we have one of the equal parts shaded in. So our unit fraction here, 1/7. Moving on to number 8, the whole has been divided into 1, 2, 3, 4 equal parts. So 4 is our denominator, and then one equal part is shaded in, so our numerator is 1. Our unit fraction for number 8, 1/4. Now for numbers 7 and 8, those rectangles are the same size. So if we were to compare those unit fractions, which is greater, 1/7 or 1/4? Well, we can see that 1/4 is greater. That's a larger shaded part. But also we can look at the denominators when it comes to unit fractions. Whichever denominator is less, that will be the greater unit fraction. 4 is less than 7. So 1/4 is greater than 1/7. And think about it. For 1/4, that rectangle was only divided into 4 parts. So those parts are larger compared to 1/7, which was divided into 7 parts. So that will make those parts smaller. So there's the basics of unit fractions and what they are. Let's move on to fractions of shapes. In this section, we're going to write a fraction to represent the shaded part of each shape. Let's jump right into our examples, starting with number 1. So what fraction of this shape is shaded? Let's start with the bottom number of the fraction, the denominator. That's going to be the total number of equal parts a whole has been divided into. So how many equal parts has the whole square been divided into? 1, 2, 3, 4. And that's our denominator. So 4. Now we need the top number, the numerator. That's going to be the number of equal parts that are shaded out of the whole. So 1, 2, 3. That's our numerator. So we can see that 3 out of 4 parts are shaded. Our fraction is 3 over 4, which we say 3/4. Let's move on to number 2, and we will start with the denominator. So how many total equal parts has the whole been divided into? Well, 1, 2, 3, 4, 5, 6, 7, 8. So we have a denominator of 8 here. Now for the numerator, how many equal parts have been shaded? 1, 2, 3, 4, 5, 6. So our numerator is 6. We have 6 out of 8 parts shaded. Our fraction is 6 over 8, which we say 6/8. Moving on to number 3, let's start with the denominator again. So how many total equal parts has this whole rectangle been divided into? 1, 2, 3. So 3 is our denominator. Now we need the numerator. So how many equal parts are shaded? 1, 2. So 2 is our numerator. 2 out of 3 parts are shaded. Our fraction, 2 over 3, which we say 2/3. Moving on to number 4, let's start with the denominator. So how many total equal parts has the whole been divided into? 1, 2, 3, 4, 5, 6. So 6 is our denominator. Now we need the numerator. So how many equal parts are shaded? 1. So 1 is our numerator. 1 out of 6 parts are shaded. So our fraction, 1 over 6, which we say 1/6. Next, for number 5, let's see how many total equal parts the whole has been divided into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is our denominator. And as far as the numerator, we have 1, 2, 3, 4, 5, 6, 7 equal parts shaded in. So our numerator is 7. 7 out of 10 parts are shaded. So our fraction is 7 over 10, which we say 7/10. And then lastly, for number 6, let's see how many total equal parts our whole has been divided into. We have 1, 2, 3, 4, 5. So 5 is our denominator. Now for the numerator, so how many equal parts are shaded? 1, 2. So 2 is our numerator. 2 out of 5 parts are shaded. So our fraction is 2 over 5, which we say 2/5. So there's how to write a fraction to represent the shaded part of a shape. Let's move on to fractions of a group. Now let's take a look at fractions of a group. Remember, a fraction is part of a whole. The whole can be one object, or in this case, the whole is going to be a group of objects. So fractions can represent part of a whole group. Let's jump into our examples, starting with number 1, where we have what fraction of the triangles are blue. So for numbers 1 and 2, we have a group of triangles. This is our whole group. So for number 1, we need what part of that group is blue? Well, let's start with the denominator. The denominator is going to be the total number of parts in the whole group. That's going to be the total number of triangles here. We have 1, 2, 3, 4, 5 total triangles. So that's going to be our denominator. Now we need what fraction of that total amount of triangles are blue. Here's one blue triangle, and here's two blue triangles. So 2 out of the 5 triangles are blue. 2 is our numerator. So what fraction of the triangles are blue? 2/5. Let's move on to number 2 and try another one. So what fraction of the triangles are green? Well, we know that our denominator is 5. That's the total number of triangles. So let's put our denominator of 5. And now we need our numerator. So how many triangles out of the 5 total triangles are green? Well, 1, 2, 3. So 3 is our numerator. So what fraction of the triangles are green? 3/5. Let's try a few more examples and move on to numbers 3 through 5. Taking a look at numbers 3 through 5, we're going to be working with a group of donuts here. Let's start with number 3, where we have what fraction of the donuts have chocolate frosting, so brown frosting. Let's start with the denominator. So we need to figure out how many total parts make up the whole group. How many total donuts make up the whole group? We have 1, 2, 3, 4, 5, 6, 7, 8 total donuts. So 8 is our denominator. Now we need the numerator. That's going to be the number of donuts that have chocolate frosting. We have 1, 2, 3, 4. So 4 is our numerator. 4 out of the 8 donuts have chocolate frosting. So our fraction is 4/8. Let's move on to number 4, where we have what fraction of the donuts have pink frosting. We know that we have 8 total donuts, so that's going to be our denominator. And now for the numerator. So how many of the 8 donuts have pink frosting? 1. So 1 is our numerator. 1 out of 8 donuts has pink frosting. So our fraction is 1/8. And then lastly, number 5, we have what fraction of the donuts have blue frosting. So again, we know that we have 8 total donuts, so that's our denominator. Now we need the numerator. So how many of those 8 total donuts have blue frosting? Well, 1, 2, 3. 3 out of the 8 donuts have blue frosting. So 3 is our numerator. Our fraction is 3/8. So there's a little bit about fractions of a group. Let's move on to fractions on a number line. Let's take a look at fractions on a number line. We will start with identifying fractions on a number line and then move on to drawing fractions on a number line. Let's jump into number 1, where we need to figure out the fraction being represented on that number line. Now notice, we have 0 and 1 here. So a distance from 0 to 1. We can think about this like one whole. And we can see that the green point marking our fraction is in between 0 and 1. So we don't quite have 1. We have part of that distance, part of that whole. This is going to be a fraction. The first thing that we need to do is see how many equal parts, equal lengths, the distance between 0 and 1 has been divided into. This is going to be our denominator. We have 1 equal part, 2 equal parts, 3 equal parts, 4 equal parts. This tells us we have fourths. This is 1/4 of the distance between 0 and 1. This is 1/4. This is 1/4. And this is 1/4. Each equal part is 1/4 of the whole. So again, our denominator is going to be the total number of equal parts between 0 and 1. So 4 is our denominator. Now we need to figure out our numerator. That's going to be the number of equal parts the point is from 0. So going from 0 here, we are 1, 2, 3 equal parts away from 0. So 3 is our numerator. Our fraction is 3/4. And looking at the number line, this makes sense. One whole is divided into 4 total equal parts, equal lengths. And the point is 3 out of the 4 total parts away from 0. So to wrap up number 1 and help our understanding of fractions and number lines, let's label everything on this number line. We start with 0, which is just 0/4. 0 out of the 4 equal parts. Then going from 0 to the first tick mark, that's 1/4. 1 out of the 4 equal parts. Or think 1/4 of the distance from 0 to 1. Then from 0 to the second tick mark is 2/4. 2 equal parts out of 4, or think 2/4 of the distance from 0 to 1. Then we have 3/4, which is labeled, and that was our fraction for number 1. So 3 equal parts out of 4, or think 3/4 of the distance from 0 to 1. And then lastly, we have 4/4, 4 out of the 4 equal parts, which is just one whole, that full distance to 1. Let's move on to number 2. We will start with the denominator. So we need the total number of equal parts between 0 and 1. We have 1 equal part right here and 2 equal parts right here. So 2 is our denominator. Now we count the number of equal parts the point is from 0. Well, 1. So 1 is our numerator. Our fraction for number 2, 1/2. And we can see that the point is halfway in between 0 and 1. So this makes sense. Let's move on to number 3, and we will start with the denominator. How many total equal parts has the distance between 0 and 1 been divided into? Well, 1 equal part, 2 equal parts, 3 equal parts, 4 equal parts, 5 equal parts. So we have fifths here. Each part is 1/5 of the whole. Our denominator here is 5. Now for the numerator. So how many equal parts is the point away from 0? 1, 2 equal parts. So 2 is our numerator. Our fraction for number 3, 2/5. And let's label the rest of this number line as well. So we start with 0, 0/5. Then we have 1/5. Then 2/5. Then 3/5, then 4/5, and then 5/5 is one whole. Lastly, let's take a look at number 4, and we will start with the denominator. So how many total equal parts has the distance between 0 and 1 been divided into? 1, 2, 3, 4, 5, 6, 7, 8. So 8 is our denominator. We have eighths here. Each part is 1/8 of the whole. Now for the numerator. So how many equal parts is the point away from 0? 1, 2, 3, 4, 5. So 5 is our numerator. This number line represents 5/8. And we might as well label the rest of the number line here. So we start with 0, 0/8. Then we have 1/8, 2/8, 3/8, eighths, 5 eighths, 6 eighths, 7 eighths, and then 8 eighths is 1 whole. So there's how to identify fractions on a number line. Let's move on to drawing fractions on a number line. Here's our section on drawing and representing fractions on a number line. Let's jump into number 1 where we have 2/3. Step 1, we need to draw a number line from 0 to 1. So again, a number line here from 0 to 1. So we have a distance from 0 to 1 now, and this is 1 whole. 2/3 is part of a whole. We have a fraction. So 2/3 is going to be somewhere in between 0 and 1. So the next thing that we need to do is divide the number line, the distance between 0 and 1, into equal parts. Our denominator tells us how many total equal parts we need. So for number 1, our denominator is 3. So we need 3 equal parts. So 1, 2, 3. Now keep in mind, we just need 2 tick marks to make 3 parts. Don't make 3 tick marks because that will give us 4 parts. Now that we have 3 total equal parts, we move on to step 3, where now we need to count a certain number of equal parts from 0 and mark the fraction with a point. The numerator tells us how many equal parts we need to count. Our numerator for number 1 is 2. So we count 2 parts from 0 and mark the fraction with a point. So 1, 2. So our point goes right here. And that's our fraction, 2/3. So let's label our fraction 2/3, and we are done. The distance between 0 and 1 was divided into 3 equal parts, so thirds. Then we counted 2 out of those 3 equal parts and marked our fraction 2/3. So we went over 2 out of the 3 total parts. Let's move on to number 2 and try another one. We have 1/6. First, let's draw our number line from 0 to 1. So here's our number line, and we need 0 to 1. 1/6 is going to be somewhere in between 0 and 1. Now we need to split the number line into equal parts. Our denominator is 6, so we need 6 in total. So 1, 2, 3, 4, 5, and 6. The distance between 0 and 1 is now divided into 6 equal parts. So we need to count and go over 1. That's our numerator. So we need to count and go over 1 equal part and mark our fraction. So this is 1/6. The distance between 0 and 1 was divided into 6 equal parts, and we went over 1 out of those 6 equal parts to represent 1/6. Let's move on to number 3, where we have 4/5. First, we need our number line from 0 to 1. Next, we need to split the number line into equal parts. Our denominator is 5, so we need 5 in total. 1, 2, 3, 4, and 5 equal parts. So fifths. The distance between 0 and 1 is now divided into 5 equal parts, so we need to count and go over 4. That's our numerator, so go over 4 out of the 5 equal parts. So 1, 2, 3, 4. And thinking about fifths as we count, that was 1/5, 2/5, 3/5, and 4/5. So just another way to think about it. Now we can mark our fraction here and label it. So 4/5. Lastly, let's move on to number 4. We have 3/8. Let's start with our number line from 0 to 1. Now for eighths here, we're going to do something a little different to help us try and stay as equally spaced as possible. Now, do you have to do it the way I'm going to do it? No, but it's something to keep in mind. First, we're going to split the number line in half. Now we're going to divide each of those parts in half. So in half and in half. Now we have 4 total equal parts. So lastly, we're going to divide each of those parts in half. So in half, in half, in half, and in half. And now we have eighths, 8 total equal parts. So we went from 2 equal parts to 4 equal parts to 8 equal parts. Now we need to count and go over 3 equal parts. That's our numerator. So 1, 2, 3. So we went 1/8, 2/8, 3/8. And we can mark and label our fraction. So 3/8. The distance between 0 and 1 was divided into 8 equal parts, and we went over 3 out of those 8 equal parts to represent 3/8. So there you have it. There's a mini course on the basics of fractions. I hope that helped. Thanks so much for watching. Until next time, peace.